any leadership or blue team or defensive practitioners who are dealing with their detective security controls, they know that we're not just writing detection rules for fun. We need to treat them as being just as important as our preventative controls. So as I mentioned earlier, if you've got people logging into your security tools and are able to create, update, or delete your detective security controls like on a whim or without any testing or approval, that's something that Detection as Code, I think, addresses.
Detection as Code is not just possible in AWS Azure, but all three of them these days. And today I had a chance to speak to David French, who is a staff adoption engineer for security at Google Cloud. And we spoke about if you're starting Google Cloud today, or if you come from an AWS and Azure background, you went through an M&A and now you're multi-cloud because of Google Cloud. This is the episode for you, because in this episode, we spoke about how do you even start doing detection in Google Cloud? What are some of the logging requirements you need to maintain? What are some of the foundational pieces you need to have in your team when you start building detection, and how do you scale that across a large amount of Google Cloud accounts? Now, in this conversation, we also spoke about the skill set and the challenges of doing so. What is a good detection, the indicator type, the behavior type, and if you know someone who is working towards building a detection as code capability, perhaps they're starting today because they recently found out they have Google Cloud in their environment as well and really large footprint of it, this is definitely the episode for them. And if you have been listening or watching a cloud security podcast episode for a while, this is probably your fourth or fifth time, I would really appreciate if you can take a moment on whichever audio or video platform that you're listening or watching this on, whether it's YouTube or LinkedIn or Apple or Spotify. Definitely take a second to hit the subscribe and follow button, because it means a lot to have your support with us and helping us get known with more people. Thank you so much for supporting, and I hope you really enjoy this episode of Detection as Code as much as I enjoyed talking to David, and I'll see you in the next episode. Peace. Hello, welcome to another episode of Cloud Security Podcast. Today I have David French with me. Hey man, thanks for coming on the show.
Yeah, thanks for having me.
First of all, I know we have the topic of detection as code, but before we get into any of that, if you can share a bit about yourself, your professional background, so people get an idea about what the journey you've traveled and where you are these days.
Yeah, sure. I've been in security now for about 10 years. I'm currently at Google Cloud. I'm a staff security engineer by trade, specialized in detection engineering. I started off as a SOC analyst. I moved on to detection engineering, threat hunting for financial institutions and large software development companies. I've also worked on the vendor side as a security researcher and engineer, building out SIEM and EDR products and developing detection content for those platforms. Yeah, I'm currently at Google Cloud. This is a role where I'm advocating for defensive security practitioners who use Google SecOps. And yeah, that's currently where I'm at. Love to share knowledge, blog in, speaking at conferences, sharing code, all that kind of stuff. More recently, I've been sharing kind of best practices and example code and tutorials for people to get started with implementing detection as code.
So what is detection as code for people who may have not been introduced to that concept yet?
Yeah, detection as code. This is something that's been appearing in conversations more frequently the last 4 to 5 years. Essentially, detection as code is applying software development practices to the creation and management of detection content. And when I say detection content, I'm talking about rules that identify certain behaviors or signatures. Yeah, so really with that, you're borrowing DevOps practices that have been around for a while. You're using things like GitHub, software development platforms, CI/CD tools like GitHub Actions and GitLab CI/CD, all that good stuff.
So I guess maybe to paint a bit more idea for people as well, what was it before? I guess obviously what happens in a non-detection as code world? Obviously, specifically if we can talk about Google Cloud as well, but in the kind of talks you give and the people you talk to as well, what's the pre-detection as code world and which led us to this path?
Yeah, so the traditional approach is, let's say you work in a SOC for a large financial institution. Just as an example, you have tools like a SIEM, an EDR, firewall, email gateway, all of these tools. And yeah, this traditional approach is people are logging into those tools manually, right, in the UI. They're making use of detection content from vendors that's already there. They might be writing their own custom detections. So they're really operating in the UI and making changes, creating rules, dealing with the whole life cycle of a rule in all these various tools. So with that approach, and by the way, that's still fine for many companies if you're a smaller company with a smaller team, but potential shortcomings or pitfalls of that are changes are being made by individuals without input testing, review, approval from anyone else on the team. And in my experience, what I've seen is people make mistakes, right? You can blow up your SOX queue with false positives or page people out of bed if you make a mistake, tuning a rule. Or worse, you miss behavior, right? Whether it's an attacker coming at you and you find out after the fact that someone tuned a rule and it led to false negatives, or I've experienced the red team coming at the blue team, right? And then you miss stuff and whole team feels bad. Leadership are asking what's happened. It's terrible for morale. So yeah, those are some of the shortcomings with that traditional approach. But like I say, still works for some teams, right? If you're a smaller team, smaller company.
So is this more of a, and because you're talking specifically about SOC in Google Cloud environments, but what is what you said, there are so many different parts people have to look at, especially in the SOC team. It's just not your Google Cloud. You're looking at probably some kind of email gateway, whether it's G Suite or something else. You also have other components, other applications, other softwares. You also mentioned earlier that people may be using GitHub Enterprise or some kind of CI/CD pipeline. Just to give some idea for people, is that more from a security operation practice perspective, what is the incentive for, say, any director or VP of security operation listening to this, who may be in a small organization or maybe in a mid to large or large enterprise kind of organization? What is the business ROI to even validate why do we need to invest time into detection as code? Because sounds to you what you said, maybe it's a good thing, but what's the business ROI with it?
Yeah, I think any leadership or blue team or defensive practitioners who are dealing with their detective security controls, they know that we're not just writing detection rules for fun. We need to treat them as being just as important as our preventative controls.
Yeah.
As I mentioned earlier, if you've got people logging into your security tools and are able to create, update, or delete your detective security controls like on a whim or without any testing or approval, that's something that detection as code, I think, addresses, right? I think the first step, thinking about implementing it or the value of it, right, is that you've got all these tools that we mentioned before, SIEM, EDR, firewall, and you've got existing detection content out there.
Yeah.
The first step really is like taking inventory of what you have, pulling it into a single location. So you've got a single source of truth.
Yep.
And then deciding on, okay, what's my schema? What's my change control process around these? Am I going to test for regressions when anyone is suggesting changes? And then who needs to approve it before those changes get deployed out to my tools? So it's really just, I think, a sign of maturity moving towards that kind of method where you're just taking your detection content more seriously and giving it that care and feeding and those guardrails around it to control changes that happen to it.
I think you touched on something really interesting over there as well. In terms of most of the security products people work with, they're all about threat detection. And we're already doing detection kind of world anyways. And my primary assumption has always been hey, prevention is probably the best part. Like prevention is better than cure, as they say. But prevention is really hard to do and it takes a longer time. In the meanwhile, detection is the one secret weapon you can keep using to at least every time a bad behavior or something which should not happen at least occurs, you have some kind of detection for it. And it almost feels, the reason I asked for the business ROI thing is because a lot of times when people start working on it, it almost feels like asking how long is this piece of thread question. Whereas that, hey, what am I? And obviously the answer may be different for different people, but I'm also thinking about people who are building a security operations team in the cloud today, maybe specifically Google Cloud as well. What are some of the foundational pieces they would have to consider? And by the way, this doesn't just for small companies, but it could be people who already have AWS Azure, now have Google Cloud coming in. I don't know what kind of detection or SOC security operation I should be doing for Google Cloud. So maybe to lay the groundwork from maybe some native services, perhaps Google Cloud has, or what can people consider when they are building a security operation capability for their Google Cloud business?
Yeah, I think so. Google SecOps comes to mind, which is our security operations platform driven by Google Threat Intelligence. But before we dive into that, we can talk about some of the logging that's available in Google Cloud, right? So just the fundamentals, understanding what logs are available to you and what events are logged when certain things happen in your environment is a good foundation. So starting with Google Cloud audit logs, think of these as the who, what, when, where of things happening in your environment, right? Creating an audit trail. So subtypes of that, you have admin activity logs. They're always enabled, can't turn them off. Things like a service account key being created in your environment, or two-step verification policies being changed, storage bucket policies being changed, that kind of thing. So just important or notable things happening in your environment. And then you have data access audit logs. So think of this as API calls being logged when access is happening to storage buckets or database queries are being run, that kind of thing.
Yep.
That volume is obviously going to be quite high if you turn everything on. And if you ship it to whatever SIEM you use, you're gonna run up a large bill if they bill you by volume. So there are filters you configure, right, to decide what gets sent to your third-party system, whether it's your SIEM or Google SecOps.
Yep.
And yeah, other important ones to call out, really, I would say you've got cloud DNS logs, who's calling out to what, any command and control or crypto mining kind of call outs happening, that kind of thing. DLP events, Cloud Armor gives you visibility into web app attacks that might be happening. And then, of course, if you use Google Workspace, all that stuff, people accessing your data, making changes, admin activity, any suspicious email activity coming through. So Google SecOps being our security operations platform, right? What we have in there are things called curated detections, and they're developed by Google Threat Intelligence. And think of those as packs of rules, right? So if you use Google Cloud or Google Workspace or Okta, AWS, think of these like main platforms, right? You find in a modern enterprise. We have rule packs for those to detect suspicious or outright malicious behavior, right? And those are developed by, Google Threat Intelligence. And what SecOps does as well, it ingests intelligence feeds from various sources as well, right? One might be data from VirusTotal, right, on files or IP addresses or domains. You might have another one that detects activity from Tor IP addresses or IP addresses associated with VPN or anonymization services, all that stuff. So what we do with those curated detections or those packs of rules, we tell you which logs you need to onboard into SecOps to feed those rules events in the detection engine. Essentially, you're being strategic about what data you want to filter and ship to your SIEM, right? Because A, cost, you need to be mindful of.
Yep.
And B, if you're looking for a needle in a haystack and you're just onboarding everything, just background noise of systems just existing and doing their thing, you're just making that haystack even bigger, right? You're making it harder for your analysts or detection engineers to find that signal in the noise, really. So yeah, I'd say start there.
Because as you said that, and coming from like one of those AWS Azure kind of background, I'm sure there are people who are in that space hearing this conversation going, okay, I know certain things in Azure and AWS kind of thing. For example, the way someone would do security in a AWS or Azure would have an identity pillar to begin with. That, hey, so there's the concept of local AWS users called IAM users. Essentially, the idea is that it's not just the Active Directory enterprise users that I have, but I also happen to have local users. You mentioned service accounts earlier. It's a good example of it. Non-human users or all of that. So that was your cloud audit logs. That kind of covers that, and you can put some detection for it if you want. And then you're going to go a step layer into your network security, for lack of a better word, in terms of detection, where you have the access for storage devices, probably some web-facing services as well. But a lot of people may also have virtual machines, projects that they're running, policies they want to have from policies could be prevention policies, but are there for the different kinds of workload? Like most of these workloads these days are Kubernetes, or I don't know anyone's doing virtual machines anymore, but most people seem to go down the path of Kubernetes these days. But if people had both, what are some of the things they can look out for there from a threat detection that they could use from a logging perspective to set the right foundation, and also to start maybe addressing some of the tactical things quickly that they can look at?
Yeah, I think probably thinking about like compute instances and just typical suspicious behavior that might stand out in your environment. So we've got detection content for things like reverse shells, right, in compute instances.
All right.
Or if you're doing infrastructure as code at your company, is someone logging into the console and making changes suspicious, right? Or should changes only be made by certain accounts? And if someone's logging in and making changes, whether it's an admin, right, who's bypassing processes, or an attacker, you could look into that. And then, there's other low-hanging fruit like audit logging getting disabled, people changing
But is this like a playbook in SecOps, or would you say SecOps is the? I'm thinking more. There's a similar one in AWS called Amazon Guard Duty, which is like a threat detection, threat intelligence service, which looks
Yeah.
at, say, the top 5 services within AWS to know, hey, who is doing crypto mining, who's being doing SSH brute force, who is potentially being attacked, or someone's like a malicious DNS, the kind of things you called out. So is SecOps like a managed service from Google Cloud for threat information that people can use to build detection on in their SIEM, or does it come with a pack like the ones in Azure Sentinel, where you can actually make your own playbooks? What's the if you double click on the whole Google SecOps thing, so people understand that a bit more, because a lot of people prefer using natives from the cloud provider because you get a lot more, for a bit of a bang for your buck. There's a lot more integration in there. So how would you describe Google SecOps from that perspective?
Yeah. So Google SecOps runs on Google Cloud, right?
Yep.
And think of it as doing more than a traditional SIEM, right? You can certainly ship logs to it,
Yep.
it ingests them, it parses them into a normalized schema, so you can easily search across data sources. You've got those curated detections that I mentioned that run over those logs and detect not just cloud, but endpoint behavior as well and all that, right?
Oh, so, like G Suite and everything.
So yeah, there are Google Workspace packs, but I'm also talking attacker tradecraft on Windows endpoints and Active Directory and all that, right? So it's not just cloud. And yeah, like you mentioned, there's a rules engine running in there, and you can go into that and write your own custom detections.
Yep.
Because as detection content, there's not a one size fits all approach.
Yeah.
I've worked at a vendor before where I'm writing detections to run on thousands of customers, and there's just some tuning and baselining that needs to go into that.
Yep.
So SecOps, to expand on that, it's also got SOAR capabilities.
Okay.
It also does enrichment of your events automatically. So you could ingest the metadata from all of your Google Cloud resources into SecOps. So when an alert fires or an events log, it's enriched with all that information. So I have to go in my console and start clicking around usernames, metadata about departments or compute instances, buckets, all that stuff. So all this stuff that we would be clicking around trying to connect the dots, it does that for you. So you can spend more time worrying about detection and response and investigation, essentially, instead of the quality of your data. In addition to that, we've got this thing called Security Command Center Enterprise. It also runs on Google Cloud. And you can think of that as a multi-cloud solution that helps you detect and respond to threats, right? So it works with Google Cloud, AWS, Azure.
Yep.
So when you have that, think of that as adding a CNAP to SecOps.
All right. Okay. Wow.
Yeah. So with that, you have all of those detection kind of content packs I mentioned earlier that run on those platforms. But it also gives you the ability to configure policies and rules in your environment. So the ones out of the box will be mapped to things like NIST controls, right? So if compute instances shouldn't have a public IP address assigned, it can flag for that. If you've got things like overly permissioned or overly privileged service accounts, it will just flag these things, right, when your environment starts to drift. And it can either fix them automatically, or it can just alert you with a risk score, right? And then another cool thing it does, it's got this thing called virtual red teaming. And what it will do, whichever of those kind of big cloud service providers you use, right, it will go in and it will grab the metadata from everything in that environment. And then what it does, it graphs that out, and then it runs these red team playbooks against it to see where your weaknesses are.
Oh, wow. Okay.
Yeah. So things like I mentioned overly permissioned service accounts. If you've got poorly managed SSH keys, where if an attacker exploited an instance and got in, it will highlight where they can move laterally to further infiltrate your environment.
Yep.
Yeah. So things like that. Yeah. And that's our multi-cloud kind of CNAP solution.
Interesting. So based on a MITRE framework for cloud, root cause for cloud incidents, they found that one of the top 3 was more around, hey, compromised keys or credentials. And people talk about, hey, the threat intelligence feed that Google SecOps has, does that kind of include that information as well? So it looks at the fact that, hey, by the way, I see compute instances using a compromised SSH was just found in GitHub or wherever, it flags it. Does that kind of thing would be like one of the low-hanging fruits that people can look at as well?
Yeah, I don't think SecOps does that out of the box. I can come back to that, but Security Command Center Enterprise definitely
Okay.
to
Also,
leak
sorry, maybe
secrets.
I've spoken the wrong product, but so the security
That's
command center
okay.
I think does do that as well.
It does, yeah, yeah. And if you use a service like GitGuardian or Trufflehog, words fail me, maybe SemGrep does that as well, I think.
Yeah,
You
yeah.
can certainly ingest those alerts into SecOps. And then you could have that either presented to an analyst in a case, or you could link that to a playbook where you could go out and remediate, right? You could rotate the secret or disable an account or whatever your response action might be. So, yeah, there are other ways to integrate that information. If you're already paying for a service that does that kind of keeping an eye on the web to see if anything is leaked or gets out.
Fair. And to what you mentioned, the different kind of threats as well. People can have their own custom detections that they want to create. I guess when we were talking about this earlier, you were talking about the different kinds of detection, like the two kinds you mentioned. Like, what are the kind of detections people can expect that they can work with, or they should consider as they start building on that? I want to say it as like a detection engineering capability. Maybe Google Cloud becomes that first cloud in their organization where they start building detection engineering capability because of capabilities like Google SecOps and Security Operations Center. How would you describe the kind of different kinds of detection people can create, and as if there's an intelligent way of doing it as well?
Yeah. So I think understanding if I'm a detection engineer starting a new company, right, and I'm tasked with figuring out what detection content we currently have, what logs we have, what our vendors supply us with, and like how I can build upon that to increase my coverage, right? Because
Yeah,
every organization is different. So yeah, understand your organization and the vertical you operate in and the threats to your organization. So what attack groups are known to come at your organization? What are their typical tactics, techniques, and procedures? That kind of thing. Typically, you will want to make use of the intelligence sources you already have. So if you're paying for Google Threat Intelligence or any other vendor that's providing you with feeds of either indicators or their own rules, you want to certainly deploy that or correlate indicators over your logs, looking for things like activity happening in your environment coming from VPN or anonymization services that your company hasn't approved for use, right? If I use, I don't know, Palo Alto's Global Protect as my VPN client and everyone at the
yeah,
company uses that, someone coming from NordVPN, I definitely want to take a closer look at that, right?
yeah,
So taking care of those kind of detections, like what's happening in the wild, what is my intelligence telling me, capitalizing on that and exhausting all of that first. And then in terms of looking for, I'm talking about Google Cloud again, right? Defending my
yeah,
Google Cloud
yeah,
environment. Typically, if you have a detection and response engineer or a SOC analyst who's looking at logs and writing detections, they might not be an expert cloud security engineer. So one thing I've had success with at other companies is make friends with your engineers and admins, right? Get them on a call and workshop. Hey, what's your day job? What are the 5 things that should absolutely not happen? They'll say, oh, okay, we don't allow service account key creation, or maybe we do from a couple of accounts. So that will be suspicious because we use workload identity federation instead, or we use Terraform to manage all of our environment or our infrastructure. So if anyone's logging into the console and making changes, that will be suspicious. So yeah, making friends with your admins. And at a large enterprise, you might not be the person identifying data sources and deciding what gets onboarded to your SIEM or whatever platform you use, right, for monitoring and detection. So making friends with admins so you can get into the console with them and look at the logs, like what. I'll give you an example. GitHub Enterprise has got audit logs. And if you turn those on and ship them to your SIEM, out of the box, they don't log the source IP address in the event.
oh,
So you could have a detection that looks for a personal access token being created by a GitHub user, and they've
yeah,
cloned 100 repos. You go, okay, what's this guy doing? Like, where's he? Where are they coming from? And you don't have the IP address. So that's a prime example of don't just turn a data source on and ship everything to your SIEM without kind of understanding the data source and exploring the settings and carrying out some actions or simulating some attack behavior and seeing what data you get.
yeah.
Because by the time an alert fires and you go and look at the alert, you're disappointed, right? Because your data is incomplete or missing.
Mm, yeah, fair. And I guess
I won't
maybe,
tell you how. I won't tell you how I found out that one.
yeah, I was gonna say I didn't realize it doesn't have the source IP, which makes it a bit more
You have to turn it on.
scary.
Yeah.
Considering it's probably like the place where your source code is as well, and you want to be
Oh
aware
yeah.
of who's using it and where. So maybe they can check out one of your talks about it because I think you laid out something which is really interesting. The whole idea behind whether you're building a detection based on an indicator or whether it's a behavior based one. How does one, once you start building it, how do you scale it out into obviously we're talking about a very small example of one Google Cloud account, but I don't think it's common anymore to just have one Google Cloud account these days. I don't know which company probably has hundreds going on at any given point in time. How does one scale detection? Say, for example, to what you said, you may hear this conversation or watch this conversation and make one detection out of this because, hey, I spoke to, I don't know, Jennifer in the development team and she gave me this information. Now I know that, oh, I need to look for some kind of secrets across my entire Google Cloud. I'm just making up an example here into my GitHub
Yep.
enterprise. Now, if it was a Google Cloud specific detection, how do you scale that from one account where you've tested it, you're like, yep, David, I'm happy with this, to scale it out to hundreds of Google Cloud accounts or maybe thousands?
Yeah, this is a prime application for detection as code. Going back to that, yeah, let's imagine someone in your organization has given you some intelligence or an idea on a new detection they want to put in place. My process, if I jump into my SIEM or whatever I have and start writing detection logic without having the underlying events when that behavior is carried out in my environment, you're essentially shooting in the dark there. So what I like to do is in a lab environment or a dev environment, right? I'll pretend I'm the adversary and carry out those actions or simulate that behavior. And this will generate the events in my logs that I want my rule to match on, right? By that point, I'll decide if I want to just have a single event rule, right? Think of that more like a signature, right? Something happened, one event, or detect on a sequence of behavior or a cluster of behavior happening correlated by a user account or a host or an IP address, right? Someone is enumerating my billing settings in a Google Cloud project or organization, right? Maybe they move on to spin up a bunch of compute engine instances. Maybe they've got hold of an account that can assign other permissions to itself. So they start doing that. So whether these events happen in a sequence or a cluster of behavior, or whether you've implemented some kind of risk scoring, I generally start there, right? So you've got your initial version of your detection logic. If you write a rule, you own it. So I wouldn't just throw that over the fence and start alerting my SOC or detection and response engineers, especially if it's paging them out of bed, right? You're just going to annoy people and it wastes time. But yeah, you write it, you own it in that sense. So I would probably monitor that detection for a week or two, depending on how much of, if this is an emerging threat versus attacker tradecraft that's been out there for a while and something I just want coverage from my organization. So I would eat my own dog food, right? I'm getting alerts from that, from maybe one project or two projects in Google Cloud. I'm tuning it based on what's normal for my organization, any anomalies that might happen. And then, yeah, essentially going back to detection as code, if I've got that in, say, my code base in Git, and I've defined which log types or what logs from which Google Cloud project this detection is running on, I can easily change that when I'm ready to scale it and define what projects or orgs I want that rule to run on. Yeah, and then going from there, really, so you're not really done at that point. When you have a detection, you're constantly responding to alerts from it, triaging alerts, tuning it, and eventually technologies come and go. You might have, if you're never doing any testing or review, you might have a rule that's running and not being fed any logs, or is trying to detect the behavior for an application your company doesn't even use. So it's this life cycle, right? You're never really done.
And I think at some point in our conversation, you also mentioned data pipeline as well. Where does that kind of fit into all of this?
Yeah. So again, yeah, people are talking a lot more about, in terms of detection engineering, people are talking a lot more about data pipeline, data quality, or some people using the term data fabric. It means you're not just shipping logs to a centralized location, right, like a SIEM, and running detection rules over that. You're not done at that point. People are caring a lot more about data quality these days. So when you think about that data pipeline, something happens, an event is logged, somewhere along the line that event gets paused and you're writing detection rules for it. As I said before, environments drift, right? So data quality issues happen, right? There might be latency between the event getting logged and it get into your detection engine. Vendors, this is probably the most annoying one. Vendors change their logging schemas, right?
Yeah.
They change their logging schemas on us. It's just a fact of life. And field names change, or values in a field that your rule is matching on changes, and your detection breaks silently. And then you miss behavior, or it just sits there for months, right? And no one notices. Yeah, when we think about a data pipeline, it's just caring more about the quality of the data that you rely upon. And if you're a detection engineer, I almost guarantee it, no one cares about the quality of that data as much as you do, right? We spoke about a large enterprise where you've got admins looking after different clouds and different SaaS applications, that kind of thing. They might turn on the logging for you and ship it to where your detection engine is, but they don't care about the quality as much as you. Implementing what I like to call health checks or probers. I care about my Google Cloud audit logs. I can just have a health check that reaches out to my Google Cloud environment, carries out this kind of test action, whether it's just a simple API call from a certain account. And I can have a rule running that's monitoring for that behavior. It fires an alert. It gets closed by my source and no one ever has to look at it. But if that doesn't happen, right, every hour or every 6 hours or every day, whatever cadence I'm doing it, my team gets an alert to say, hey, we're no longer getting these logs, or they're not being parsed properly, or there's latency. So really, I think just being more proactive about the care and feeding of your data, that's where the data pipeline kind of stuff comes in.
So being a bit more intentional about building your own pipeline so you can feed more detection in the future as well.
Yeah, absolutely. Yeah, like I said, you don't want to ship the kitchen sink from a cloud environment to your SIEM. You're going to run up a bill and increase the amount of noise that someone's going to have to wade through.
Yeah.
But yeah, just being more deliberate about what you filter, what you sanitize, what you transform, what you enrich. That all falls under data pipeline management, in my opinion. Yeah.
And I guess, are there any top 3, maybe not difficult, but maybe easy detections that come to mind that people can actually test out themselves? And I don't know, could be anything, could be a storage device supporting the internet or whatever comes to mind for people to get their feet with, hey, sounds like a great idea, I probably should start doing it. Are there any common detection scenarios that come to mind that people can dive into as a starting point without it could be quite overwhelming going to another developer and finding out that there are these 25 things that they hate about the application that you have to create detection for? Are there some easy detections people can try out themselves to wet their feet a bit and then start building from it?
Yeah, thinking about long-lived credentials, right? Service accounts is a good example. So if you allow service account keys in your environment, just exploring or baselining or understanding, like, what does service account key use or creation look like? Who's creating them? What's my process to create them? Looking at the kind of key rotation interval as well, right?
Yep.
So if you've got one that's only rotated once a year, like dive into that and look into that. It's not always about detection. You can also explore and build your case to implement better prevention, right? Or controls. So if we do allow service account keys, can we rotate them every 30 days? Are there workloads, GitHub Actions, GitLab CI/CD, Circle CI, like insert vendor name here? What does service account key usage look like in that environment? If someone gets hold of that key, are they going to have access to my environment to carry out actions for 6 months? Or can we move to something that's more secure or aligns with best practices like workload identity federation, right? Going back to my detection as code pipeline, right? I use workload identity federation in GitHub Actions. When that calls out to my Google Cloud environment, that token is only valid for 3 minutes, which is more than enough to manage my detection content in my security tools. Yeah, just, I don't know, maybe want to get started, some homework, find what does that look like in my environment, in my Google Cloud audit logs.
Yeah, and to your point, the logs are available in Google Cloud anyways to begin with, so they can perform the action themselves and see what events get triggered, to what you were saying earlier as well, to really know what they would be building detection on top of.
Yeah, absolutely. Yeah, and like I said, every organization is different. So just baselining, understanding what's normal, and then going from there, really.
So what would be for the security operation senior people or the leaders in there who probably would like to have some maturity to their detection? They maybe already have common detections already there. What would be the different maturity stages for like a crawl, walk, run phase for building a detection as code capability?
Yeah, I think take an inventory of what you have, right? What detection content is currently in my tools? What does my vendor provide out of the box? What am I making use of there? And then figuring out, do I have a single source of truth for my detection content, whether you're pulling everything back to a code base like in GitHub, understanding what that coverage looks like, right? What are my data sources that I care about? What do I have today? Mapping rules to MITRE ATT&CK, right, is just something that we've been doing for years, and it's a valuable exercise. Unless you're playing bingo and just saying I've got one detection per cell and high-fiving. Yeah, firmly against that. Yeah, once
Bingo.
yeah. Or I won't go there. MITRE ATT&CK evals, we've got 100% coverage, right? Anyway, yeah. So do I have that single source of truth for my detection content? Do I understand my current coverage, where my gaps are, where I want to go there? Do I have change control over my detection content, or can someone just log into my tools and disable it or modify it?
Yeah, actually, that's a good one. Yeah, that's a good one.
And then just measuring things like this emerging threat comes out, like how quickly can I create and deploy a detection? How quickly can I handle detection tuning when someone reports a false positive or misbehavior? Things like how quickly can I roll out changes to detections? What's my mean time to detect? When I think of mean time to detect, performing some analysis and reporting around when the event occurred, when my detection fired, and when someone picked it up. If something happens in my Google Cloud environment, for instance, and I don't get an alert for 3 hours later, depending on what that was, the attacker could have carried out a lot of actions. Yeah, so some food for thought there, I think, or recommendations. I'd also recommend checking out Kyle Bailey's Detection Engineering Maturity Matrix. He's mapped everything out by people, process, technology in steps, or stages: defined, managed, optimized. So if you're running a detection engineering program or just getting started, I think that's a great resource as well.
Actually, talking about running a team for detection, what kind of skill sets do you think people need these days for? We're talking about building detections, data pipelines. Sounds a lot more than what people traditionally believe a SOC analyst is these days, though. What are some of the skills that people at that level need now?
Yeah, absolutely. Yeah. Starting with SOC analysts, right? If you've got that investigative or defender's mindset where you might not be able to write code, you might not be familiar with software engineering practices, but if you're able to explore logs and do log analysis or triage an alert and figure out if it's a true or false positive, when the behaviors in our environments, I think, more complex now than just, Windows endpoint got popped and I have to worry about domain admin. We're talking about cloud environments where you might pick up an alert and that asset doesn't even exist in your cloud environment anymore, right? It's just something that's spun up and spun down, but there are logs there. Yeah, if you can pick apart alerts and analyze logs and come to conclusions, you're still definitely an asset to your security team, and we need those people. Like, the defender's mindset is hard to teach. And then, building upon that, so detection engineering, I think people have been writing rules and signatures for decades, right? But I think detection engineering is a discipline where you care about data, the quality of your data. You care about picking apart attacker tactics, techniques, and procedures, how to simulate them, what logs do I need, like how do I code and stitch APIs together, and what's the art of the possible in terms of not just writing a query in a SIEM query, like a SIEM search box, but how can I stitch together like various data sources, do enrichment, alert on anomalies, really diving deeper than just writing a signature that matches on an indicator. But yeah, those detection engineers or data geeks, right? People who care about the quality of data. And yeah, I think in what we do as detection engineers, people who also have basic and intermediate knowledge of software engineering, DevOps practices, right? So being able to write Python code to stitch together APIs, basic knowledge of how CI/CD pipelines work, version control in GitHub, that kind of thing. Yeah, so I think some skills there would make up a solid team. And I think practitioners with kind of unique experiences and skill sets will always make the best detections, right? So you might have someone who's an amazing network engineer, someone who knows Windows endpoint and attacker tradecraft there, someone who knows Google Cloud, AWS. So you can't know it all, right? So it's just people have just got different things they can bring to the table.
Be more collaborative. I think that's pretty much where we're going with this as well.
Yeah, absolutely. Yeah.
Awesome. That's most of the technical questions I had. I've got 3 fun questions for you as well, man.
Okay.
Just about you. So we'll be theming through them really quickly as well. First one being, what do you spend most time on when you're not trying to do detection as code and solve that world of detection? What do you spend most time on?
Outside of work?
It could be anything. Yeah, outside of work, at work.
Yeah. Let's do outside of work. So I'm a Brit living in Colorado. I've been here for 5 years now. If you like the outdoors, this state is just a playground, right? I think I've got an addiction to buying outdoor gear now. Like I've filled up my garage with everything you think of. So yeah, when I'm not working, I'm disconnecting from technology. I'm fishing, hiking, kayaking. That's
awesome.
Yeah.
Oh, that sounds like a fun activity as well. Second question, what is your favorite cuisine or restaurant that you can share with us?
Favorite cuisine? It changes. At the moment, it's Indian food because I can't get good Indian food where I live in Colorado. So.
I mean, being a Brit, I can totally understand that. The UK definitely has great curries, but I don't know, man. Colorado has the outdoors, but not the curries.
Yeah, the food where I live isn't great, but luckily my wife is a good cook.
Oh, nice.
I picked up an Indian cookbook, so I've been trying my hand at dal and lentils and curries and all that. Yeah, I miss that. Whenever I go back to England, I have my fill.
Perfect. But dude, thank you so much for answering those as well. And where can people find you and connect with you online to talk more about detection as code and how Google SecOps can help them perhaps better their detection in their organization?
Yeah, I think I'm most active on LinkedIn these days.
Yep.
I was going to say for better or worse. Yeah, I think I'm most active on LinkedIn these days. You can find me doing stuff on GitHub. I publish on Medium sometimes. I think I'm most active on our Google Cloud security community at the moment with my job. So yeah, if you've got any questions, you can reach out, LinkedIn or Google Cloud security community. I'm around there. Yeah, that's where you can find me.
Awesome. I'll put those in there as well. But dude, thank you so much for coming in. And I really enjoyed the conversation. So I'm looking forward to having more of these as people try and make more detection happen in the Google Cloud. But thanks so much for coming in.
Yeah, thanks for having me. It's great. Thank you.
Thanks, everyone. Thank you so much for listening and watching this episode of Cloud Security Podcast. If you've been enjoying content like this, you can find more episodes like these on www.cloudsecuritypodcast.tv. We are also publishing these episodes on social media as well, so you can definitely find these episodes there. Oh, by the way, just in case there was interest in learning about AI cybersecurity, we also have a sister podcast called AI Cybersecurity Podcast, which may be of interest as well. I'll leave the links in the description for you to check them out. And also for our weekly newsletter, where we do in-depth analysis of different topics within cloud security, ranging from identity, endpoint, all the way up to what is the CNAP or whatever a new acronym that comes out tomorrow. Thank you so much for supporting, listening, and watching. I'll see you next time.